Hello and welcome to this module on transformer. Navigation tour. Sound control. Next button from here. Thanks, you have completed the course. By the end of this module, you will be able to define transformer and its working principle, explain construction of transformers, draw phasor diagrams of working of transformer, make an equivalent circuit of transformer, list different types of transformer as per applications, execute tests and maintenance of transformer, and protect transformer from different faults.
हाँ मनु सर।
हाँ वो क्या कर रहे थे?
अब वो बोल रहा था ना कि अभी तो पटना से पॉसिबल नहीं है आप लोग आना, तो वही मैं बोल रहा था कि इमरान को जो है आप थोड़ा गाइड कर दीजिएगा।
ये आपका मशीन किस लोकेशन पे लगेगा?
ये लगेगा यहाँ APR महिंद्रा है ना?
कहाँ पे, पटना में कि बाहर?
नहीं नहीं, गया में।
तो अभी तो हम लोग को अलाउ भी नहीं ना पटना से बाहर शूट करने का।
अच्छा।
मतलब हम लोग ये होम वर्क कर सकते हैं, मतलब पटना में बैठ करके वर्क कर सकते हैं।
हाँ।
अगर नौकरी कंप्लीट आया तो खाली पटना में जा सकते हैं, बाहर अलाउ नहीं है।
अच्छा, चलिए ठीक है, कोई इशू नहीं है। और अच्छा, ये एक चीज मैं बोल रहा था कि ये जो प्री साइट रिक्वायरमेंट है, तो मुझे जो है 3 चीज मालूम है कि CVD चाहिए, गैस चाहिए 134A, और अर्थिंग चाहिए, ठीक है ना? तो ये
और ऑयल भी बोला था।
ऑयल कौन सा है जिसके बाद?
लास्ट टाइम चेक किया था ना मैंने।
क्या बोल रहे हैं?
लास्ट टाइम मैंने चेक किया था ना, जब गया में इंस्टॉलेशन था कार्लो से।
तो 3 चीज का ये आया था, तो वही मेल को मैंने देख करके जो है कार्लो वाला ही कॉपी पेस्ट किया।
साइड ऑयल चाहिए था तो खैर साइड ऑयल तो वहीं मिल ही जाएगा।
कौन सा? जरा लिख के, हाँ वो जरा व्हाट्सएप कर दीजिएगा, कौन सा ऑयल चाहिए, कितना टाइप का ऑयल चाहिए, तो सो दैट कि वो उस मेल पे ही मैं आगे मतलब ये कर दूंगा।
नहीं बोल, लेकिन मेल डालने से पहले एक बार टेलीफोनिक जरूर मैसेज डाल देते, ऐसा हो नहीं सकता। क्योंकि क्या है ना,
हाँ।
अभी मेरे साथ जब हो सकता है मैं किसी पे बात कर रहा हूँ, होता क्या है दोनों चीज एक ही में पड़ा है।
अच्छा,
तो ऐसा हो सकता है। और आपके पास दोनों नंबर है मेरे?
नहीं, एक ही नंबर है आपका।
अच्छा। तो भाई अब आपको मेल डाल दिया, यही है ऊपर बात मालूम चलेगा, नहीं होगा कि बात ही नहीं करते।
नहीं, मेल आपको ही खाली किए हैं भाई, किसी को ये नहीं रखे हैं, आपकी कंपनी के कोई दूसरे आदमी को नहीं रखे हैं CC में। तो CC में आप चेक कीजिए, CC में सिर्फ ईगल का ही
देखा है, आपके ही ऑफिस के लोग हैं, बात हुई नहीं है।
हाँ, बस आपको ही किया।
आपको कर दे रहा हूँ क्या क्या रिक्वायरमेंट है, ठीक है?
हाँ, अच्छा, उसी मेल पे कर दीजिए कि वो ये रिक्वायरमेंट है, मतलब तो दैट मुझे भी याद रह जाएगा। ठीक है,
ठीक है
ठीक है। या तो फिर नया मतलब मेल ड्रॉप कर सकते हैं, तो नया कर दीजिएगा।
ठीक है ठीक है।
ठीक है, चलिए, ओके।
We have heard the word transformer a lot in daily lives, but what it is? Transformer is a static AC device used to change high voltage low current AC into low voltage high current AC and vice versa without changing the frequency. In brief, it transfers electric power from one circuit to another. It does so without a change of frequency. It accomplishes this by electromagnetic induction, where the two electric circuits are in mutual inductive influence of each other. The operation of transformer is based on
हाँ,
बंदे का नंबर भेज रहा हूँ, ठीक है?
अच्छा,
मेरा नाम बोल दो, उससे बात करना है, अभी जी सर बात बोल दो, उसका नाम सुबह है, ठीक है?
ओके,
बोल रहा है और सारा डिटेल्स बता दे देना।
ठीक,
मूवमेंट बहुत स्लो हो रहा है, तो मैं चलाने में टाइम लगेगा, ठीक है?
अच्छा,
और उससे अपना बात करो, कैसे क्या है, पैसे कैसे तो वो प्रैक्टिस से लेना देना है, तो क्या है, पहले पे करो, जो भी ये बात करो, सारा डिटेल्स समझा देगा, समझ लेना, ठीक है? हाँ,
चलिए, ठीक है।
on the principle of mutual induction, according to which an EMF is induced in a coil when current in the neighboring coil changes.
can wait or call again later. आपने जिस व्यक्ति को कॉल किया है वो
In this section of the module, we will understand the construction of transformer. From the core construction perspective, transformer is of two types, that is, shell type and core type. Click each to know more. In core type transformer, windings are wrapped around two sides of a laminated square core. Here, the representation of core type transformer is given. Here, the construction of core type transformer is shown. In shell type transformer, windings are wrapped around the center leg of a laminated.
हेलो, हाँ शुभम जी बात कर रहे हैं क्या? मैं नाजिम बात कर रहा हूँ ईगल ऑटोमोटिव से। आपका नंबर अमित जी ने दिया है। जी, तो सर ये प्रोडक्ट जो है वो है ये कंप्रेसर है, ठीक है। क्या बोल रहे हैं? हाँ, पैकिंग वैकिंग किया हुआ रहता है। आपको पैकिंग, हाँ फरीदाबाद से नहीं, नोएडा से, ग्रेटर नोएडा से। हाँ, ग्रेटर नोएडा से पटना होना है सर। नहीं, फरीदाबाद से दिल्ली का क्या है, पटना आएगा ना सर। हाँ, पटना में डिलीवर होना है। हाँ, ओके, ठीक है, बात बता दी कौन। हाँ, ओके, ओके, तो सर, तो दोनों में कितना डिफरेंस आता है सर? ओके, अच्छा, नहीं जैसे अगर अच्छा, तो अभी उसमें मतलब प्राइस में कितना फर्क पड़ेगा वो थोड़ा अगर पता चल जाए तो। वेट देखिए, देखिए 4 कंप्रेसर है, ठीक है। मैं या आप एक काम कीजिए सर, कॉन्फ्रेंस में ले सकते हैं तो कॉन्फ्रेंस। अच्छा, ठीक है सर। आपका नाम क्या है? नाजिम, NAZIM। सर आपको भी 5 मिनट में कल कॉल करेंगे। चलिए ठीक है, आपके साथ कोऑर्डिनेट करते हैं ना। ठीक है, थैंक यू।
Core. Here, the representation of shell-type transformer is given. Here, the construction of shell-type transformer is shown. For better understanding of construction, click each of the following concepts and know more. High voltage conductors have smaller cross section than the low voltage coils. Here is the sectional view of shell type transformer, and this is the sectional view of core type transformer. High voltage conductors have smaller cross section than the low voltage coils. Here is the construction of shell type transformer using stampings. Here is the construction of core type transformer using stampings. Click each image to know more. This image shows the coil and laminations of core type transformer. And here are the various types of cores. We take round shaped core to have minimum winding copper wire. This image shows the coil and laminations of core type transformer. And here are the various types of cores. We take round shaped core to have minimum winding copper wire. The HV and LV windings are split into number of sections, where HV winding lies between two LV windings. In sandwich coils, leakage can be controlled. Let us look at the cut section of transformer to understand it more clearly. Frame or tank. It protects the transformer core and coils and provides mechanical support to all accessories. Core. It provides the magnetic path for the magnetic flux. Windings. These provide the path for electric current. Radiators. It is used to improve the cooling efficiency of transformer. Drain cock. It is used to collect and drain the transformer oil. Rollers. These are used for transportation of transformer. High voltage bushing. It provides support for high voltage terminal with proper insulation.
Hello? Okay. मतलब हम फोन करें
क्या बोले आप फोन करके सारे लड़कों से पूछो और अपने हिसाब से कस्टमर से भी पूछो कि सर मशीन जो लगा है वो सब सही चल रहा है क्या प्रॉब्लम है वो प्रॉब्लम नोट करो उसमें कि हाँ ये लोकेशन है ये मशीन है ये कस्टमर है इसका ये प्रॉब्लम है ठीक है तो नोट आपको तो भेजो ताकि अभी क्या है कि जैसे ही कब अभी नॉर्मल होगा कंपनी का सर्विस इंजीनियर सब लड़कों के साथ भेजो उसको सारा प्रॉब्लम सॉल्व करेगा
चलो ठीक है
वो फटाफट भेजो सॉल्व कर देना
ठीक है
आगे आगे बात कर सकते हो
ठीक
যে ব্যক্তিকে আপনি কল করেছেন তিনি এই মুহূর্তে অন্য কলে ব্যস্ত আছেন অনুগ্রহ করে অপেক্ষা করুন বা কিছুক্ষণ পর আবার কল করুন যে নম্বরে আপনি কল করেছেন সেটি বর্তমানে ব্যস্ত আছে অনুগ্রহ করে কিছুক্ষণ পরে চেষ্টা করুন आपके द्वारा डायल किया गया नंबर अभी व्यस्त है कृपया कुछ समय पश्चात
Low voltage bushing. It provides support for low voltage terminal with proper insulation. Conservator. It provides space for the wire during change in temperature. Explosion vent. It is an emergency safety device to protect from high pressure inside the transformer.
transformer oil. It is stable at high temperatures and has excellent electrical insulating properties.
Buchholz relay. It is a gas-operated relay which gives alarm during overload and trips in case of severe fault inside transformer. Temperature gauge. These are of two types, OTI, that is oil temperature indicator, and WTI, that is winding temperature indicator. Breather. It inhales dust and moisture-free air inside the transformer. Let's understand the working of transformer with conservator and breather. Conservator allows extra space for transformer oil to contract and expand due to heat produced because of loading of transformer. While inhaling, breather allows dry air to go inside the transformer, and during exhaling, the air inside the transformer is released in the atmosphere through it. Breather consists of oil pot and silica gel. Oil pot catches dust of air that goes inside during inhaling, and silica gel absorbs moisture of the air. Color of dry silica gel is blue, and after absorbing the moisture, the color of the silica gel becomes pink. Now, let's look at the working of a transformer. 1. When current in the primary coil changes, being alternating in nature, a changing magnetic field is produced in the core. 2. This changing magnetic field gets associated with the secondary winding through the soft iron core. 3. Hence magnetic flux linked with the secondary coil changes. 4. Which induces EMF in the secondary winding. Depending on the electrical network where the transformer is installed, there are two transformer types, three-phase transformers and single-phase transformers. Let us learn about single-phase transformer. The AC voltage source injects the AC current through the transformer primary winding. The AC current generates the alternating electromagnetic field. The alternating magnetic field gives rise to alternating flux in the iron core of the transformer, thus inducing voltage in the primary as well as secondary windings. Thus, the voltage is induced in the secondary winding with same frequency as voltage of the primary side. The induced voltage value is determined by Faraday's law. ERMS equals to 4.44 into F into N into phi max, where F is frequency hertz, N is number of winding turns, Phi is magnetic flux WB. The single-phase transformers can operate as step-up transformer or step-down transformers. In this section of this module, we will learn about the ideal transformers. An ideal transformer is an imaginary transformer which does not have any loss in it. For better understanding, we have divided it in two following parts: terminologies, circuit and phasor diagrams. Click each to learn more. Here are few terms that we need to understand first. Zero leakage flux. Flux is produced by the primary and secondary currents are confined within the core. The windings have no resistance, that is, induced voltage equal applied voltages. The core has infinite permeability. It means the following two conditions. Reluctance of the core is zero. Negligible current is required to establish magnetic flux. Lossless magnetic core, that is, no hysteresis or eddy currents. In an ideal transformer, the leakage flux is considered nil. That means 100% flux passes through the core and links with both the primary and secondary windings of transformer. Although every winding is desired to be purely inductive, but it has some resistance in it which causes voltage drop and I²R loss in it. In such ideal transformer model, the windings are also considered ideal, that means resistance of the winding is zero. Now, if an alternating source voltage V1 is applied in the primary winding of that ideal transformer, there will be a counter self EMF E1 induced in the primary winding which is purely 180 degrees in phase opposition with supply voltage V1. As the primary winding is purely inductive, that current 90 degrees lags from the supply voltage. This current is called magnetizing current of transformer I mu. This alternating current produces an alternating magnetic flux phi which is proportional to that current and hence in phase with it. As this flux is also linked with secondary winding through the core of transformer, there will be another EMF E2 induced in the secondary winding. This is mutually induced EMF. As the secondary is placed on the same core where the primary winding is placed, the EMF induced in the secondary winding of transformer E2 is in the phase with primary EMF E1 and in the phase opposition with source voltage V1. Do you know the EMF equation of transformer? Click to view the equation. Do you know the EMF equation of transformer? Click to view the equation. Do you know the EMF equation of transformer? Click to view the equation. In this section of this module, we will understand transformer in different conditions with help of circuit and phasor diagrams.
Drag and drop each voltage bushing on transformer.
Click each to know more. A transformer is said to be on no load when its secondary side winding is open circuited. When an AC sinusoidal supply is connected to the primary winding of a transformer, a small current I.O. will flow through the primary coil winding due to the presence of the primary supply voltage. With the secondary side open, that is, when no load is connected to the secondary side, a back EMF along with the primary winding resistance acts to limit the flow of this primary current. Obviously, this no-load primary current I.O. must be sufficient to maintain enough magnetic field to produce the required back EMF. This no-load primary current is made up of the following two components. An in-phase current, IE, which supplies the core losses. A small current, I mu, at 90 degrees to the voltage which sets up the magnetic flux. Here, the figure shows the phasor diagram of a transformer on load by assuming 1. No voltage drop in the winding. 2. Equal number of primary and secondary turns. As shown, direction of induced EMF is opposite to applied voltage. But direction of induced EMF in primary and secondary will be same.
And the primary current is divided into two components as shown.
गाड़ी खुद पकड़ा रहा है। आपने बोली बोला
When an electrical load is connected to the secondary winding of a transformer, the transformer loading is therefore greater than zero. A current flows in the secondary winding and out to the load. This secondary current is due to the induced secondary voltage set up by the magnetic flux created in the core from the primary current. The secondary current IS, which is determined by the characteristics of the load, creates a self-induced secondary magnetic field Ys in the transformer core, which flows in the exact opposite direction in the main primary field Phi P. These two magnetic fields oppose each other, resulting in a combined magnetic field of less magnetic strength than the single field produced by the primary winding alone when the secondary circuit was open-circuited. This combined magnetic field reduces the back EMF of the primary winding, causing the primary current IP to increase slightly. The primary current continues to increase until the core's magnetic field is back at its original strength. And for a transformer to operate correctly, a balanced condition must always exist between the primary and secondary magnetic fields. This results in the power to be balanced and the same on both the primary and secondary sides. As we just mentioned that several losses occurs when a transformer runs on load. Let us look at different losses that occurs in a transformer. Iron losses. Iron losses are caused by the alternating flux in the core of the transformer. As this loss occurs in the core, it is known as core loss. Iron loss is further divided into hysteresis and eddy current loss. Hysteresis loss. The core of the transformer is subjected to an alternating magnetizing force, and for each cycle of EMF, a hysteresis loop is traced out. Power is dissipated in the form of heat, known as hysteresis loss. The iron or core losses can be minimized by using silicon steel material for the construction of the core of the transformer. Eddy current loss. EMF circulates currents within the body of the conducting material of the core. These circulating currents are called eddy currents. As these currents are not responsible for doing any useful work, and it produces a loss I2R loss in the magnetic material known as eddy current loss. The eddy current loss is minimized by making the core with thin laminations. Copper and ohmic loss. These losses occur due to ohmic resistance of the transformer windings. Stray loss. The occurrence of these stray losses is due to the presence of leakage field. The percentage of these losses are very small as compared to the iron and copper losses, so they can be neglected. Dielectric loss. Dielectric loss occurs in the insulating material of the transformer, that is, in the oil of the transformer or in the solid insulations. Let's talk about how maximum efficiency can be achieved by reducing the losses. Maximum efficiency can be achieved when core losses are equal to copper losses. We can also achieve all-day efficiency using the formula given below.
बोलेंगे ना कि चले फिर उसको क्यों नहीं करवा लेते हैं फाइनेंस करा के तो पहला बोल रहे हैं
The phase angle between the secondary current and voltage depends on the nature of the load. If the load is inductive, the transformer will be with lagging power factor. Steps to draw the phasor diagram is as follows.
Take flux phi as reference.
Induced EMF E1 and E2 lags the flux by 90 degrees. The component of the applied voltage to the primary equal and opposite to induced EMF in the primary winding. Current IO lags the voltage V1 by 90 degrees. The power factor of the load is lagging. Therefore, current I2 is drawn lagging V2 by an angle phi 2. The resistance and the leakage reactance of the windings results in a voltage drop, and hence secondary terminal voltage V2 is the phasor difference of E2 and voltage drop. V2 equals to E2 minus voltage drop. I2 R2 is in phase with I2 and I2 X2 is in quadrature with I2. Current I2 dash is drawn equal and opposite to the current I2. The total current flowing in the primary winding is the phasor sum of I2 dash and IO.
V1 equals minus E1 plus voltage drop.
I1 R1 is in phase with I1 and I1 XI is in quadrature with I1. The phasor difference between V1 and I1 gives the power factor angle
Phi 12
of the primary side of the transformer. The power factor of the secondary side depends upon the type of load connected to the transformer. Steps to draw the phasor diagram at capacitive load.
Take flux phi.
हेलो
हाँ हेलो क्या किया यादव भाई
हाँ बोलो
ये क्या बोलते हैं कि अपना है ना ये आए हुए यहाँ पर सुनार में आए हुए हैं मारुति वाले के पास तो यहाँ पर जो चेकबुक का पैसा जो फीस है उसका पेमेंट कितना था
देखना पड़ेगा यार याद नहीं है मुझे
हाँ तो याद नहीं है एक काम कीजिए
सुनो ना तुम भी तो यार इसमें मेल पे रहते हो तुम चेक करो ना अपने मेल पे चेक करो ना सारे मेल पे बिहार के सर मेल पे तुम भी हो
तो ना तो एक आप ये कहाँ आए हुए हैं आपसे मेल पता नहीं आरोप शुक्ला सर नहीं है ठीक है ना
हाँ
ये 2 महीने से नहीं आ रहा कोई और है मैंने कि हमको जरा हमको दिखाइए कैसे कैसे क्या है उसके बाद फिर हम आपको बताते हैं
तो एक काम करो ना मेल पे मतलब ये करके दिखा दो मेल पे तुम्हारे इसमें है देख लो ठीक है तुम हाँ नेक्सा और उसका दोनों का कुम्हार का दोनों का है नेक्सा और कुम्हार दोनों का है मतलब मेल पे ठीक है अलग अलग है ठीक है
I as reference.
Induces EMF E1 and E2 lags the flux by 90 degrees. The component of the applied voltage to the primary equal and opposite to induced EMF in the primary winding. Current IO lags the voltage V1 by 90 degrees. The power factor of the load is leading. Therefore, current I2 is drawn leading E2. The resistance and the leakage reactance of the windings result in a voltage drop, and hence secondary terminal voltage V2 is the phasor difference of E2 and voltage drop. V2 equals to E2 minus voltage drop. I2 R2 is in phase with I2 and I2x2 is in quadrature with I2. Current I2 dash is drawn equal and opposite to the current I2. The total current I1 flowing in the primary winding is the phasor sum of I2 dash and I0.
Primary applied voltage V1 is the phasor sum of minus E1 and the voltage drop in the primary winding. V1 equals minus E1 plus voltage drop.
I1R1 is in phase with I1 and I1XI is in quadrature with I1. Let us now understand the equivalent circuits of transformer as follows. No load equivalent circuit. Equivalent circuit parameters referred to primary and secondary sides. Approximate equivalent circuit. Click each to know more. Here is the no-load equivalent circuit of transformer. No-load current I0 is 3 to 5% of full load current. And here are some other parameters. The effect of circuit parameters shouldn't be changed while transferring the parameters from one side to another side. It can be proved that a resistance of R2 in secondary is equivalent to R2 upon K square will be donated as R2 dash, that is, equivalent secondary resistance with respect to primary, which would have caused the same loss as R2 in secondary. While transferring secondary parameters to primary side, this is how the circuit and parameters change. Similarly, while transferring primary parameters to secondary side, this is how the circuit and parameters change. Click here to see equivalent circuit with respect to primary with all parameters. Since the no-load current is 3 to 5% of the full load current, the no-load circuit can be neglected. Transformers can be classified into the following categories based on their application. 1. Distribution transformer. 2. Power transformer. 3. Current transformer. 4. Potential transformer. 5. Furnace transformer. 6. Booster transformer. 7. Rectifier transformer. 8. Locomotive transformer. 9. Mining transformer. 10. Phase shifting transformer. 11. Welding transformer. 12. High voltage testing or SC testing TRF. 13. Grounding transformers. 14. Converter transformer. high voltage testing or SC testing TRF. 13. Grounding transformers. 14. Mining transformer. 10. Phase shifting transformer. 11. Furnace transformer. 6. Booster transformer. 7. Rectifier transformer. 8. Locomotive transformer. Transformer. 9. Mining transformer. 10. Phase shifting transformer. 11. Welding transformer. 12. High voltage testing or SC testing TRF. 13. Grounding transformers. 14. Converter transformer. Here, we have the major factors that affect the selection and sizing of transformers. Transformation from which voltage to which voltage, example 11 kV to 6.6 kV. Power requirement to be met presently and in foreseeable future in terms of kVA, MVA, connected load, demand factor and diversity factor. Power factor of load to calculate the kVA, MVA rating of transformer. Harmonic content of loads to be supplied. Transformer needs to be derated for harmonic loads, K factor. Any need for supply of high currents for short duration. Unbalance in phase currents of loads. Transformers supplying single phase loads tend to have more phase unbalance in load currents. Configuration of windings. Delta, star. Based on need for neutral, filtering of third harmonic currents, tertiary winding for auxiliary supply, etc. Need for paralleling of transformers. Parallel operated transformers have to meet certain criteria such as same primary and secondary voltages, percentage impedances within a band, etc. Need for voltage adjustment. On-line or off-line tap changer. Voltage regulation and efficiency that is required. Indoor or outdoor application. Ambient temperature. Type of cooling. ONAN, ONAF, etc. Insulation medium. Oil, epoxy dry type. Dry type is a maintenance-free, does not pose fire hazards, spill hazards. Type of neutral earthing. Solid, resistance, reactance, tuned resistance based on magnitude of earth fault currents, suppression of transient voltages, system insulation, etc. Percentage impedance from the point of reducing fault levels. Higher percentage impedance reduces fault levels. Level of protections based on criticality of transformer. Mounting, pole mounting, plinth mounting. Level of pollution in the environment. Bushing design and selection depends on pollution level. Altitude of installation. Installation at above 1000 meters would need D-rating of equipment. voltage level selection is done based on the current and load requirement. The voltage level is categorized as 480 volts, 2400 volt, 4160 volt, and so on for better selection based on the requirement.
Click each tab for more information.
Next, let's look at some important terms that affect the voltage level selection: load forecasting, demand factor, and diversity factor. Click each tab for more information. Load forecasting is a technique used by power or energy providing companies to predict the power or energy needed to meet the demand and supply equilibrium. The accuracy of forecasting is of great significance for the operational and managerial loading of a utility company. Demand factor is the ratio of the sum of the maximum demand of a system or part of a system to the total connected load on the system or part of the system under consideration. Demand factor is always less than 1. Diversity factor is the ratio of the sum of the individual maximum demands of the various subdivisions of a system or part of a system to the maximum demand of the whole system or part of the system under consideration. Diversity is usually more than 1. Now, since you know the formulas, let me ask you a question. Do the calculations and enter your answers. There are 4 individual feeders having connected loads of 250 kVA, 300 kVA, 350 kVA and 100 kVA. Demand factors for these are 80%, 70%, 75% and 90% respectively. Diversity factor is 1.6. Calculate 1. Total demand of loads. 2. Size of transformer required to supply these loads.
Click each tab to see the solution.
I have one more question for you. Here are the quantities that we know, and based on these, please calculate the capacity of transformer in kVA.
बोलिए।
बिजली बिल जमा कर देंगे।
कौन बोला?
हम पूछिए।
अब बोलिएगा तो चले जाएंगे।
हम नहीं चालू करेंगे, लाहौर चले जाएंगे। हैं?
तो फिर बोल कहाँ ला रहे हैं फिर?
बोलने से चला दे।
So, let's begin with our next topic. Testing of transformer is carried out as per IS 2026. Transformer testing is done in 3 ways. 1. Routine tests. 2. Type tests. 3. Special tests. Click each tab for more information. Routine tests are carried out on each job and can be classified as follows. 1. Measurement of winding resistance. 2. Measurement of insulation resistance. 3. Separate source voltage withstand test. High voltage tests on HV and LV. 4. Induced over voltage withstand test. DVTF test. 5. Measurement of voltage ratio. 6. Measurement of no load loss and current. 7. Measurement of load loss and impedance, efficiency and regulation. 8. Vector group verification. 9. Oil PDV test. Click each tab for more information. This test measures the resistance of the HV and LV winding. The values of resistance should be balanced for all 3 phases and should match the designed values. Equipment used is digital resistance meter. Measures the insulation resistance of HV and LV windings with respect to earth, body and between LV and HV winding. Insulation tester or megger is used. Recommended values are 2000 N ohms for HV and 500 N ohms for LV. This test checks the insulation property between primary to earth, secondary to earth, and between primary and secondary. HV high voltage test. LV winding connected together and earth. HV winding connected together and given 28 kV for 11 kV transformer for 1 minute. LV high voltage test. HV winding connected together and earth. LV winding connected together and given 3 kV for 1 minute. Equipment used is high voltage tester, 100 kV and 3 kV. This test checks the inter-turn insulation. For a 11 kV upon 433V transformer, 866 volts are applied at the 433V winding with the help of a generator for 1 minute. This induces 22 kV on 11 kV side. The frequency of the 866V supply is also increased to 100 Hz. Equipment used is motor generator set. This test measures the voltage ratio as per the customer's requirement. The voltage ratio is equal to the turns ratio in a transformer. V1 upon V2 equals to N1 upon N2. Using this principle, the turns ratio is measured with the help of a turns ratio meter. If it is correct, then the voltage ratio is assumed to be correct. Equipment used here is turns ratio meter. The iron losses and no load current are measured in the test. The 433V winding is charged at 433V supply and the 11 kV winding is left open. The power consumed by the transformer at no load is the no load loss in the transformer. Effect of actual frequency must be taken into account. Equipment used are watt meters or power analyzer. This test measures the power consumed by the transformer when the 433V winding is short-circuited and the rated current is passed through the 11 kV winding. This test verifies the DYN11 vector group of a distribution transformer. Here, vector group means angular displacement between HV and LV of same phasor. For example, capital R and small r. Equipment used here is voltmeter. Oil breakdown voltage is checked as per IS-335. This includes 100 mm length into 70 mm breadth into 80 mm height glass pot, 500 milliliter oil sample, spherical electrodes with gap of 2.5 mm. Recommended value is 60 kV. Type tests are carried out only on one transformer of the lot. They are done to check the design and process parameters. They include all routine tests. Additionally, following tests are included in type tests. 1. Lightning impulse test. 2. Temperature rise test. Lightning impulse test. All the dielectric tests check the insulation level of the job. Impulse generator is used to produce the specified voltage impulse wave of 1.2 upon 50 microseconds wave. One impulse of a reduced voltage between 50 to 75% of the full test voltage and subsequent 3 impulses at full voltage. For a 3-phase transformer, impulse is carried out on all 3 phases in succession. The voltage is applied on each of the line terminal in succession, keeping the other terminals earthed. The current and voltage wave shapes are recorded on the oscilloscope and any distortion in the wave shape is derived.
Hello?
अभी उसको जो वहाँ पे ट्रांसपोर्टेशन डिवाइस हम लोग नहीं किए हैं तो उसको अभी करना पड़ेगा, समझे?
आज के डेट का
आज ही के डेट का करना पड़ेगा ना, देखो होगा ना वैसे।
अच्छा
ये सब कुछ लोग आज के डेट से कर सकते हैं ना, बोला कि माइक्रो मिस हुआ है उसको करेंगे, ठीक है?
ठीक
पहले जो वीडियो बता देना उससे मिस हुआ है तो आज हम लोग कर सकते हैं ना, आज के डेट में कर सकते हैं, आज का समाज के अंदर बताओ।
ठीक
Criteria for failure.
लो लिख दो जरा
Special tests can be categorized as follows: additional impulse test, short circuit test, measurement of zero phase sequence impedance test, measurement of acoustic noise level, measurement of harmonics of the no load current, magnetic balance test, short circuit withstand ability test. This test measures the ability of the transformer to withstand the mechanical and thermal stresses caused by the external short circuit. HV terminals are connected to the supply bus of the testing plant. The LV is short-circuited. The testing plant parameters are such adjusted to give the rated short circuit current. Supply is made on and closed after specified duration of short circuit. The record of current waveform is noted. There should not be any mechanical distortion prior to the transformer during this test. Similarly, no waveform distortion. The transformer should also withstand the routine tests after the short circuit test. The reactance of the winding measured before and after the SC test should not vary beyond the limits stated in the IS 2026. Transformer is the heart of any power system. Hence, preventive maintenance is always cost-effective and time-saving. Any failure to the transformer can extremely affect the whole functioning of the organization. The maintenance procedure for any transformer includes the following guidelines. First screen. Oil. 1. Oil level checking must be done and leakages must be attended. 2. Oil PDV and acidity checking should be done at regular intervals. If acidity is between 0.5 to 1 mg/kOH, oil should be kept under observation. 3. PDV, color and smell of oil are indicated. 4. Sludge, dust, dirt, moisture can be removed by filtration. 5. Oil when topped up shall be of the same make. It may lead to sludge formation and acidic contents. 6. Insulation resistance of the transformer should be checked once in 6 months. 7. Megger values along with oil values indicate the condition of transformer. 8. Periodic dissolved gas analysis can be carried out. Bushings. 1. Bushings should be cleaned and inspected for any cracks. 2. Dust and dirt deposition, salt or chemical deposition, cement or acid fumes depositions should be carefully noted and rectified. Breather. Periodic checking of any loose connections of the terminations of HV and LV side must be done. Breather examination or dehydration of silica gel must be done if necessary. Explosion vent. Explosion vent diaphragm examination is also important. Conservator. Conservator must be cleaned from the inside after every 3 years. OTI and WTI. Regular inspection of oil and winding temperature meter readings must be done. Cleanliness in the substation yard must be done with all nets, vines, shrubs removed.
आ रहे हैं लो
The best way of protecting a transformer is to have good preventive maintenance schedule. The maintenance schedule includes taking care of all temperature indicators, winding temperature indicators, Buchholz relay, magnetic oil level gauge, explosion vent, HT fuse and DO fuse, LT circuit breaker, HT circuit breaker with overload, earth fault relay tripping, oil surge relay for OLTC, PRV for OLTC, horn gaps and lightning arrestor, breather.
अभी भी मिल गया ये पोल से मुंह धोता होता नहीं है
तो इसे धोए ना करेगा तो खाली खाई के चक्कर में रहता है। हाँ रमजान है तेरे और सब का रमजान ना तेरे को रमजान लग रहा है, रमजान तो खत्म हो गया। सुबह तो दसमन ना कर सकता है। हाँ बड़का दसमन जी है कैसे की है
बस ना और कोई डालना मोबाइल नंबर
अच्छा खड़ा रह रहा है पिला डलाना कर रहा है।
Now that we know the measures for protecting the transformers, let's take a look at the failures that can take place in a transformer. Insufficient oil level, seepage of water in oil, prolonged overloading, single phase loading, unbalanced loading, faulty termination, improper sized lugs, etc. Power theft, prolonged short circuit, faulty operation of tap changer switch, lack of installation checks, faulty design, poor workmanship, improper formation of core, improper core bolt insulation, burr to the lamination blades, improper bracing of joints, burr or sharp edges to the winding conductor, incomplete drawing, bad insulation covering, insufficient cooling ducts in the winding, bad quality of raw material, transit damaged transformers. After failure, transformer is removed and replaced with new or repaired one without removing the cause of failure, which results in immediate or short time failure. Let us now look at the causes of these failures. Environment, system, maloperation, wrong design, manufacture, material, maintenance. The transformer failures can be classified as external failures and internal failures. They are as follows. Internal failure causes winding in terminal faults, core faults, on-load tap changer faults, overheating faults. External failure causes abnormal operation condition, sustained or unclear faults. Let's look at the fault current distribution. Let's first understand earth fault on transformer winding.
Click the zoom icon to view the diagram.
Thank you.
basic protection of transformers.
हाँ, गुड आफ्टरनून सर। और कैसे हैं सर? ठीक है सर। एक चीज़ पूछना था कि 1819 के इसमें जो है एक ट्रांसपोर्टेशन का, ठीक है, तो ट्रांसपोर्टेशन का पहला इसमें जो पीओ जो दिया गया था, तो वो पीओ मुझे दिया गया था, उसमें ट्रांसपोर्टेशन अटैक्चुअल था। बाद में मार्क्स ने जो है उसको ये किया कि ट्रांसपोर्टेशन आप पे कीजिएगा, मतलब आप हमको पे कीजिएगा, हम ट्रांसपोर्टर को पे कर देंगे, ठीक है। तो उसका वो पीओ हमको दिया नहीं था, तो हमने मतलब एक्चुअल वाला जो पीओ इनवॉइस था वो बना करके उनको दे दिया था। तो उनकी लीजर में वो शो कर रहा था कि 64,000 रुपये जो है मतलब बकाया है। तो उसको जो है आज की डेट में हम बना के ट्रांसपोर्टेशन का एक दे सकते हैं क्या? तो 89 नहीं, 1890 में बिलिंग हो गया था, ठीक है ना, मार्च मंथ में हुआ था, मार्च 2019 में। तो वो 1819 के फाइनेंशियल ईयर में चला गया।
तो अभी तो आप
हाँ, तो भी तो उसका जो है अच्छा मार्च में कर रहे हैं। तो मतलब सिर्फ ट्रांसपोर्टेशन का उसका हम ऐसा खाली एक बिल बना कर दे देते हैं।
ट्रांसपोर्टेशन का बिल आप बनाइए, मतलब पहले था कि जैसे आप माल लगाइएगा, तो जैसे
कस्टमर है, ठीक है ना, जैसे सपोज कीजिए कि हीरालाल मोटर है, ठीक है ना, हिल टॉप मोटर है। तो हिल टॉप मोटर में मतलब माल ने पहले ये उठाया था कि ठीक है, माल जो आपका आएगा आप मतलब उसको पे कीजिएगा ट्रांसपोर्टेशन। तो कितना आएगा भाई? तो मतलब 80,000 रुपये आएगा, 70,000 आएगा, जो भी आएगा वो आपको मतलब 2 पे बेसिस पर आएगा, पे करना होगा। बाद में फिर हाँ हाँ 1,10,000 नहीं, मतलब वो जो है ज़्यादा हो रहा था, मतलब वो ट्रांसपोर्टर जो है वो उसके ऊपर था कि हमको 1,00,000 का हमको इन्वाइट करना था, ठीक है ना। बाद में हीरालाल बोला कि नहीं, हम जो है 10,000 ही हम ट्रांसपोर्टेशन देंगे, बाकी के ऊपर इसके ऊपर 10,000 के ऊपर जितना भी आएगा वो आप लोग को बियर करना पड़ेगा। हाँ, आप अपने जेब से दीजिएगा, ठीक है ना। तो 10,000 प्लस जीएसटी वो आप मतलब दीजिएगा, यानी कि कुछ 12,000 रुपये ऐसा कुछ आएगा ना। तो 11,000 800 रुपये जो है हम आपको पे करेंगे। 11,800 हम पे कर देंगे आपको, बाकी का जो ट्रांसपोर्टेशन आपको जितना लगेगा ऊपर वो आपको देना पड़ेगा। तो एक्चुअली में जो है मेरे को 1 लाख का जो जो था वो खाली हमको मिला था कि पीओ की ये इसका इनवाइस बना करके दे देना है, तो वही मैं बना के दे दिया। बाद में ये ऐसा इस तरह से बात हुआ था, वो मुझे मतलब लूप में नहीं रखा गया, कोई इन्फॉर्मेशन नहीं दिया गया। कल वर्ष को जो है वो बोला गया है कि लीजर आपके इससे दिखा रहा है कि आपकी तरफ से आउटस्टैंडिंग है, मतलब 64,000 रुपये। तो फिर उससे लीजर मंगाया, फिर उसको चेक किया, तो फिर उसके बाद माल ने फिर वो भेजा कि नहीं इसमें जो है ट्रांसपोर्टेशन उसने मुझे 55,000 प्लस जीएसटी वो पे किया था, ठीक है। तो हमने बोला कि जब आपको मिला था तो मुझे भी बताना चाहिए था, तो मैं फिर उसको ट्रांसपोर्टेशन ऐड करता उसी में, तो उसमें ऐड कर करके ये कर देता था। तो बताया नहीं, अभी वो खत्म हो गया, अभी मार्च 2019 को चला गया, तो अभी इसको मार्च जो पिछले साल में मार्च 2000। ठीक है, ठीक है, थैंक यू। हाँ, कुछ बोल रहे थे आप?
बोल रहे हैं कि कितना आपका यहाँ पे रिजल्ट का बाकी है?
ये मार्च का बाकी है और फरवरी हो गया है।
मार्च का रिजल्ट बना,
हाँ वही उसका बना ही हुआ है ऑलमोस्ट, ठीक है।
आपको बिल्डिंग पैसा दीजिएगा, लेकिन मार्च का साल बढ़ जाएगा।
ठीक।
Can be done in 4 different ways: differential, restricted earth fault, overfluxing, overcurrent and earth fault. Let's deep dive into 3 main types of protection: differential protection, restricted earth fault protection, combined differential and restricted earth fault protection. Click each to know more. Click each to know more. Differential protection works on the principle of Moore's price current comparison. In this case, only relays with bias characteristics should be used. It is only applied where protection coordination is difficult or not possible using time-delayed elements. For fast fault clearance. For zone of protection.
हेलो, हेलो, हाँ
बोल रहा हूँ ना कि ये जो अमर ज्योति का जो है ना, जब पास से निकले ना, ये जो वॉइस है, मुझे आपने जो फीलिंग जो दी है ना, फीलिंग में जो गेम किया है, इसलिए आप अमर ज्योति मत दीजिए, इसमें दीजिए आप पार्टनर मोटर प्राइवेट लिमिटेड क्यों आप आगे दीजिए।
उनको जरा सा बोल दो ना कि जो चीज़ है उसको थोड़ा सा व्हाट्सअप कर देने के लिए, तुम उसे लेके व्हाट्सअप कर दो ना। कर दिया वो।
हाँ वाटर का ज़्यादा किसे करना है, जिस करना है कि आपको पार्टी वोटर प्राइवेट लिमिटेड बाकी सब बने हटा देना है, क्या बोलते हैं समझ छोटी प्राइवेट में हटा देना है। और ये क्या बोलते हैं कि उसका पॉलिसी वही रहेगा, मतलब है ना ये है ना पार्टी वोटर प्राइवेट लिमिटेड पूरा खाली कर देना है बस।
तो इसको थोड़ा सा लिख के दे दो ना, हम इसको जब करने बैठेंगे तब कर देंगे ना। अभी अभी बोल रहे हो, अभी फिर बाद में भूल जाएंगे तो ध्यान से उतर जाएगा ना।
अच्छा ठीक है उसका सब वहाँ का एड्रेस दे देते हैं।
हाँ ठीक है, ले करके उसको व्हाट्सएप
क्या होता है ठीक है ना।
और इसके अलावा भी देख लो ना कि मतलब इम्पैक्ट रेंज के अलावा भी कुछ का बाकी है, कुछ जो गया है शायद लिफ्ट उफ्ट गया है ना उसके पास।
तो यहाँ के लिए
हाँ
लेकिन जो रहेगा ना हमको भेजिएगा, ठीक है। सर को भी याद नहीं है, ठीक है ना, तो जो बोलिएगा वही हम सबसे बात करेंगे।
मगर चलिए ठीक है।
There are several considerations for applying differential protection. These include phase correction, filtering of zero sequence currents, ratio correction, magnetizing inrush during energization, overfluxing. The principle behind differential protection can be explained with the help of following circuit diagram, having an incoming feeder and an outgoing feeder. Click each image to view the enlarged version. Biased differential protection is preferred due to its fast operation, adjustable characteristic, high through-fault stability, CT ratio compensation, magnetizing inrush restraint, overfluxing fifth harmonic restraint. So, let's understand why this bias characteristic. Click each image to view the enlarged version. Click each to know more. Restricted earth fault protection uses the high impedance principle. It has increased sensitivity for earth faults, REF elements for each transformer winding, CTs which may be shared with differential element. In REF, under normal conditions, the stability level is usually maximum through fault level of transformer. So, under normal conditions, no current flows through the relay, which means no operation. Let's understand the diagram in detail. On HV side, residual current of 3 line CTs is balanced against output current of CT in neutral conductor. For LV side, ground faults occurring on delta winding may also result in fault current of less than full load. HV overcurrent relays cannot provide adequate protection. Relay connected to monitor residual current will provide restricted ground fault protection since delta winding cannot supply zero sequence current to the system. Both windings can thus be protected separately with restricted ground fault protection. This provides high-speed protection against ground faults over whole of transformer windings. Here, the relay used is instantaneous high impedance type.
कोई आदमी वहाँ तुम्हारे कांटेक्ट में दिल्ली में पहले ठीक है रमजान में तुम बरसात साथ में जाओ देखेंगे ज़्यादा बरसात साथ के वहाँ जाओ उनका प्रिस्क्रिप्शन वगैरह जो है दिखाओ और बताओ अपना क्या किया हो सकता है बरसात साहब वो जो लड़का वहाँ रहता है उसके कॉन्टेक्ट से तुम्हारा कॉन्टेक्ट करा वो लड़का जो जिनके मार्फत देखिएगा कौन है बोल रहे कि बाबू थोड़ा सा जैसे ऐसा है थोड़ा सा डॉक्टर से मशवरा करके हम बताओ या तो बोल रहे थे मेरे पास कॉन्टैक्ट है मेरा कॉन्टैक्ट करवा दीजिए उनका भतीजा है ना जो काका का भतीजा है तुम्हारा दोस्त मतलब वो हाँ उससे बोल रहे थे मेरी तबीयत थोड़ा सा ऐसी लगी है अपने पास नंबर है मामू को तबीयत उनके काम हुआ अगर जब मेरी माँ नहीं जाती तो वो भी भाई दिल्ली में उनका चल रहा है इलाज गया में क्या करिए तो बेटी है वहाँ बेटा है वहाँ तो उन हॉस्पिटल जा करके वहाँ पे कॉन्टैक्ट करके वीडियो कॉलिंग करा करके अब वापिस करा के दवाई चल रहा है और बगल में ये है जमायत वाले उनकी तबीयत खराब है सब्जी वाले राहुल शमीम में फल वाले किराना मार्केट में फल का दुकान नहीं हाँ नाटक हाँ तो इनका भी इलाज कलकत्ता में चल रहा था तबीयत खराब हो गई तो इन लोग हॉस्पिटल में कॉन्टेक्ट किए और वीडियो कॉलिंग करके काम हो रहा है प्राइवेट हाँ तो तुम्हारे पास रास्ता बताया ना लड़का के मार्फत तुम उससे कॉन्टेक्ट पढ़ने मत दो शाम में गई कैसा हालात यही पर एक्शन में आ गया वो जाके डॉक्टर से कांटेक्ट कर दे वीडियो कॉलिंग से बात करा देगा काम कर लो डॉक्टर भी जानता है कि मजबूरी है अब ये तेरे पापा की तबीयत रूबन से चल रहा है और अभी जो है यहाँ पे चेकअप वगैरह हुआ तो अब रूबन से कांटेक्ट किया अभी नहीं हॉस्पिटल का अभी कुछ नहीं होगा तो आप इनके पास नंबर था डॉक्टर का डॉक्टर को मैसेज किया कि इनको भी ऐसा ऐसा है ये है तो रिपोर्ट को देख करके वहाँ से कुछ भेजा कि रिपोर्ट अच्छा आता है मेरा परेशानी की बात नहीं दवा का दवा होता है ऐसा हाँ तो उस लड़के से कॉन्टेक्ट करो ये तुम्हारा दोस्त है उसको बोलो यार ऐसा ऐसा लग रहा है थोड़ा सा मम्मा को बोलो नहीं थोड़ा हम आ जाए वहाँ पर कोई कॉन्टैक्ट नहीं है हम बात भी करेंगे ठीक है करें अल्लाह ने कहा इब्राहिम का लिया ठीक है खुद इस्तेमाल करने के लिए है ना ये खुद ही है एक लीटर तो खाली नहीं है अब 1 लीटर बच रहा है इसमें जो पौधा किया है फ्री का देगा उसमें रेट जाता है हम लोग फ्री लेता है
It is very much possible to combine both differential and restricted ground fault protections onto one set of line CTs, or in other words, by using interposing auxiliary CTs. This in turn saves expenses of providing separate cores for each protection systems. Congratulations! You have successfully completed this training module on transformers. Now that you have completed this module, you will be able to define transformer and its working principle, explain construction of core and shell type transformers, draw phasor diagrams of working of transformer, make an equivalent circuit of transformer, list different types of transformer as per applications, execute tests and maintenance of transformer, and protect transformer from different faults.
है।